Welcome back to Unit 4, Chapter 7, Section 5. Here are the goals of I-can statements for today. After completing this lesson, I will be able to use properties of logarithms to expand them. Expand expressions, logarithmic expressions, condense logarithmic expressions using the logarithmic properties, and use the change of base theorem to evaluate various logarithms. We're also going to adapt that last one, and I'm going to show you how you can use a graphing calculator as well. So make sure you get these in your notes. Pause if you have to, go back and pause, get the goals down, and we'll see you in the morning with them hopefully for your notes. Okay, the first property we're going to look at is the product property. Expanding and condensing. Expanding means to make the expression longer, stretch it out. You're expanding your day, you're making it longer, you're stretching it out. If you're condensing things, you're making it smaller, you're squeezing it all together, so to speak. So expand is stretch it out, it's going to be a longer expression. Condensing is shrinking it, or it's going to be a smaller expression. So the product property in this case says if we have two things being multiplied and they're inside the same logarithm, we can split up each factor and add them together under their separate own logarithm, or vice versa. We can work right to left, so to speak. If we have two separate logarithms of the same base being added, we can combine them by multiplying those m&m values in one logarithm. So expanding the logarithm, if I look at log base 2 of 3x, obviously then m is 3, x is at n, so I can expand it by saying log base 2 of 3 plus log base 2 of x. Down here, I have three things, so I can do log base 7 of 14 plus log base 7 of x plus log base 7 of y. So if I have more than two things multiplied together, I just have more additions. Condensing, log base 2, log base 3 of 2 plus log base 3 of 7, they have the same base. So I can write this as log base 3 of 2 times 7, or log base 3 of 14. So that's the product property. Quotient property, that means you have a fraction. We can work both ways to expand or condense an expression as well. If you go left to right, then you're expanding. If you go right to left, you're condensing. But if I have a ratio inside of a logarithm of base b, I can separate it by subtracting log base b of m minus log base b of m, or vice versa. If they're being subtracted, I can rewrite it as a quotient. So expanding this expression, we'll look at some simple ones here. This would be log base 6 of 5 minus log base 6 of 8. So obviously whatever the numerator is, that comes first, the denominator comes second. Natural log of x minus natural log of 3. And if I wanted to condense, these both have the same basis, so this would be natural log of y over x. Now I can use both the product and property together at the same time. It says expand this. So if I see I have a ratio here, log base 8 of y minus log base 8 of 5x. Well, now if I'm expanding, I gotta expand it all the way. This 5 and x, I can use the product rule. So log base 8 of y minus log base 8 of 5x, well, let's rewrite that. That would be log base 8 of 5 plus log base 8 of x. So now you can see when we learn these properties, we're expected to use them over and over again, or in combination with each other. Okay, power property. Power property says that if I have some base being raised to a power inside of a logarithm, I can take that exponent, that power, and put it in front of the logarithm. So in other words, log base b of m to the n is n times log base b of m. And I can go backwards the other way. I can move that n back inside the logarithm and condense an expression. So expanding log base 7 of x squared, to expand that, when we bring the 2 in front, it will be 2 log base 7 of x. Over here, I have log base 5, 3 times the log base 5 of 2x, and that can be log base 5 of 2x to the third, or log base 5 of 8x cubed. Okay? So combine all the properties, expanding and condensing. So let's look at the first one. Natural log of 3x to the fourth over y to the fifth. Well, let's see this division sign. I like to get rid of that first. So I'm going to do natural log of 3x to the fourth minus the natural log of y to the fifth. I can then separate the 3x and the 4 by using the product rule. So natural log of 3 plus the natural log of x to the fourth minus the natural log of y to the fifth. And finally, I can use the power rule, and I can bring down the 4. So it's best to start with the quotient rule if you can, then use the product rule, and then finish it off with the power rule. That would be the order I would go in for simplifying. Condensing. So condensing, we reverse that order. So I see coefficients here for each of them. So I'm going to take the 3, the 7, and the 2 and use the power rule and rewrite those. 2 cubed minus log base 4 of x to the 7th plus log base 4 of y squared. So I'm going to go and I'm going to use the product rule to combine the sums here. So log base 4 of 8, so that's 2 to the third, minus log base 4 of x to the 7th y squared. Finally, we're going to use the quotient rule because these are being subtracted. Log base 4 of 8 divided by log base 4 of x to the 7th y to the 7th. That's using all the properties in one problem. Okay, change of base theorem. This theorem is very important if you don't have a graphing calculator. You just have a scientific calculator that doesn't have the logarithm app that we saw yesterday when we were graphing. If you do have that, then you don't need the change of base formula, but the change of base formula, you can use any base you want. We usually choose either log base 10 or natural log because those are the buttons that are on most scientific calculators. So basically it's saying the log base c of a value a can be found by taking the log base 10 of a divided by the log base 10 of c, or the natural log of a divided by the natural log of c. And I'm going to show you how we can do it on the calculator to get the same answer. So if we do log base 3 of 10, we don't have a log base 3 button on most calculators, but we do have a log base 10 and a natural log. So I can write this as log base 10 of 10 divided by log base 10 of 3. Or I could do natural log of 10 over natural log of 3. So in our calculator, we would simply type in log of 10 divided by log of 3. We get 2.095. I could do natural log of 10 divided by natural, divided by natural log of 3. I get the same thing. So I'm just going to slide that out. That's usually the change of base theorem. Now, we can get the same value by just plugging it in our calculator. Remember, if we hit alpha, I believe it's window, 5 is our log bases, and I can type in log base 3 of 10 right in the calculator, and I get the same number. So if you have a graphing calculator like we do in class, do the alpha window button. Okay, I'll let you guys try log base 2 of 6. It's going to be the same idea. So looking back over the lesson, I think we managed to hit all of our targets. We used the properties of logarithms to expand logarithmic expressions and condense them. And we used the change of base theorem / the graphing calculator app to evaluate logarithms of any base. So I have your notes ready for tomorrow. We'll have an assignment. We'll see you then.